Hello, students. So today we're going to go over scientific notation. We're going to try to hit two different lessons. We'll see how they go. But the first one is really diving into negative exponents. Um, so, so first we're going to start by taking just a little look at some patterns and exponents. So as you can see here, we don't really need to worry about the name. That's kind of helpful. It will be helpful at some point, but for today, not necessarily the focus. If you want to go back and look at this, I think I'll try to post the PowerPoint so you guys can look at it too. But yeah, a quintillion is 10 to the 18th. So if we count here, there's 3, 6, 9, 12, 15, 18, and then our 1. Okay, so that's 10 to the 18th. Okay, if we keep working down, we drop down to 15. You can see there's 15 zeros and then the 1. So that's a quadrillion. A trillion has 12. A billion has 9. A million has 6. 1,000 has 3. 100 is 10 to the second. Okay? But then as we get down to negative, so we get down to 0. So 10 to the 0 is going to be equal to 1. Okay, so do you see how, like, here we have 10 to the third is 1,000, 10 to the second is 100, 10 to the first is 10, 10 to the 0 is going to be 1. Okay, that's like just a rule that you have to remember. If you look at the pattern, it like makes sense within the pattern, but on its own, sometimes we're like, what? So even like other numbers to the 0 are equal to 1. So 1/10, or 10 to the negative 1 is equal to 1/10. 10 to the negative 2 is equal to 1/100th. 10 to the negative 3 is 1/1000th. Okay, so you can see this pattern, it like goes the opposite, right? Just how these were, it's basically taking the opposite, so it's going to be the opposite. So let's like, if we have 2 to the 0, our answer is 1. Any number to the power of 0 is 1. Here, let me make that a little bit bigger. Okay, any number. So if I changed this to 3, it's still 1. If I change it to 200, it's still 1. Any way you slice it, anything to the power of 0 is 1. Okay, so let's look at some negatives. So as you can see in our chart up here, it's like 1/10. What's another way that you can write 1/10 besides 0.01? You can write it as a fraction. So that's kind of one way that you can look at these, one way that you can do these. So if we have 3 to the negative 2, I did it in like the typing format and also the superscript. Also, can I teach you guys how to do superscript right now? This might be in the way. Oh, I can move it. God bless America. Look at that. Okay, so if I highlight this, I can go to format and then go to text and then go to superscript. You can also click Control plus or Control plus period. I don't know exactly what. It might zoom or unzoom your screen depending on how you do it. But you see how now that's in superscript? So when you're doing your homework, if you want to do that instead of using the caret, you can do that. Just a fun trick of the trade. I should have taught you that on the first lecture video about scientific notation. So, but basically what we're doing, and I'm going to do a little drawing here. Well, when we have something to the negative, we're saying instead of, so if it was 3 squared, right, that would just be 9, right? So instead, now we are taking it and we're putting it on the bottom of the fraction, right? Because if we have 1 to the negative 1 or 1 to the 1, whoops. No. Yes. Forget that example. I'm going to erase those, whatever. Just forget this over here. I don't know where I'm going with that. And I don't have time to think about it on this video. We'll come back to it, maybe. Okay, so this is equal to 9, but when we have negative, it's basically like we can put it into a fraction. We're looking at the opposite. So we can do 1 over negative 2. Okay, so then our answer is 1 over 9. Okay, I need my pen. So 1 over 9. Pretend those are bar lines. Okay, so that's just like a general way to do it. So when we're working in scientific notation, when we're working with like something to the tens, or like something times 10 to a power, then it's pretty easy to just use decimals like we did on the first slide. But when you're working with other numbers that aren't 10, you will have to probably put it into a fraction, okay? So, but when we're working with 10 to a power, we can just use decimals because they go nice with our number system, okay? So let's look at this, 10 to the negative 3. Okay, so we're basically doing 1 over 10 to the third. And I'm going to cut this, Control X. And I'm going to copy this one. Okay, but instead of to the negative 3, now it's a positive 3. So now we have 1 over 1,000. Okay. So we have 1 over 10 to the third. So we have 1 over 1,000, and 1 over 1,000 is equivalent to 1/1000th. Okay. So if we look at this one, so basically when we take this times this, we're moving the decimal point to the right, right? So it was 3.45. Our decimal point was there, and then we moved it over to the right. 1, 2, 3, 4, 5, right? That's how we move it in when we have a positive power. When we have a positive power, we move to the right. So when we have a negative power, we're just going to move to the left. And I got to click on my clicker. Okay, so when we have a negative, we're going to erase this. We are going to move the opposite way. So our decimal point was right here. Yes, it was right there. But now we're going to move it 1, 2, 3, 4, 5, 6, 7. Wait, did I do that right? 1, 2, 3, 4, 5, 6, 7. Oh, I did it wrong. I needed another one. 8. We're going to move it 8 to the right, so that means I need to fix my things. So if I put the decimal point right here, okay, so we move it over 8 to the right, or 8 to the left, so for negatives, we move to the left. Okay, so when we have a positive, we move to the right. When we have a negative, we move to the left. Okay, so I'm going to have you try practice set 57 for this little set of things. Okay, and then this next lesson, I think, will be relatively simple, but we're going to look at proper scientific notation. So I noticed a lot on homework and quizzes, you guys are good about, like, you're flexible in moving things around, but you don't always know what proper scientific notation is. So proper scientific notation, you always have one digit followed by a decimal point, and then all of your other digits. I'm just typing a bunch of numbers. As you can see, I put in an equal sign because I wasn't paying attention. And then you have times your 10 to whatever power it is. So let me move myself again so I can do. So 10 to the format text. Superscript, we're going to say this is to the 7th power or whatever. Doesn't really matter. Okay, but I noticed a lot of you guys, instead of having this, you would do like 435, whoops, and now it's all in superscript, 0.8769 times 10 to to the, instead of 10 to the 7th, you would do, because that would be 1, 2, 3, 4, 5, 6, 7. Would be 1, 2, 3, 4, 5. You would have this times 10 to the 5th. Okay? Which, like, these are the same, but this one right here, ding, 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 that one is in scientific notation. Okay? So we're shooting for this all the time. We want one digit. We're gonna make this green. Then the decimal point. We're gonna make this red. And then the rest of it. And then your power of 10. Okay? You can't have all of these digits floating on the left side of the I don't know what I'm saying. You only want one digit before the decimal point. You don't want to have 3 digits to the left of your decimal point. You only need 1. You can only do 1. Okay? So let's look at this one. So we have 25 times 10 to the 4th. So this is a number. This is a correct number, but this is not in scientific notation. So we originally had put the decimal to the right of, or we need to put the decimal to the right of the first digit. So we need to have this 2.5, right? Okay, and so to get it over to 2.5, we could take it times 10 to the negative 1. So basically, we are like, this little number right here, oops, this is the same as this. Okay, these two are equivalent, right? So you can take a number that's the same number times, oh, no, sorry, this is not what I want. So this number, 25, this is equivalent to 25, okay? So then we have to take this part stays with us, this part goes down here, right? We keep this part. So we're changing the format of this number to get the right, to put it into scientific notation. So, but then we can redistribute I'm going to copy this down. But now we can redistribute the parentheses. Okay, and that parentheses is small and awkward, but I'm not going to fix it. Okay, so we can move these around, and we can take 10 to the negative 1 times 10 to the 4th, and we get 10 to the 3rd. Okay, and this seems kind of complicated, but I think this is something that you will just naturally begin to do in your head. But I'm showing you like the basics of how the mechanics of it work. But I think if you just sit down and think about it, like which way do I go? Of like, yep, our decimal point in this is right here, but we need to move it 1 to the left. So that would be a negative, right? So we're going to take 1 away. Okay, so it's going to be 10 to 1 less power. Okay, so let's try going the other way. So here we have 2.5. Let's do a pink. Okay, we have 2.25. The decimal needs to be after the first digit. Okay, so this one is before the first digit, so we need to move it to after. So that is equivalent to this, right? That is equivalent to this. Okay, and then we keep our 10 to the 4th. I'm going to do green. This is the same as that. Okay, so what we're going to end up with is 2.5 times 10 to the 3rd. Okay, right? Times 10 to their 3rd, okay? Because when we have a 10 Oh, so this is another good thing to know. When you're multiplying exponents, so they have to have the same base. So, right, these are both times, or they're both 10 to a power. Right, we have 10 to the negative 1 and we have 10 to the fourth. You can just add these. When you multiply, you add. Okay, so negative 1 plus 4 is 3. I don't know if that was ever made clear to you, but I will try to make it clear to you now. Okay, so now you just add your exponents. When this base is the same, so both of these are 10, right? This is 10. This is 10. So these are the same, so then you can add the exponents to get 3. Okay? Give these a shot today. I believe in you. We can revisit tomorrow if it's really hard, but I think you'll catch on because we've been working quite a bit with scientific notation in the last month. So, good luck.